All right, recording is on. Okay, so I also posted the agenda into the chat. If everyone can see that, it's just a normal Kubernetes SIG Network agenda document. I've listed the various documents that are relevant for this meeting as links there as well. Those were also the ones that went out in the meeting invite earlier this week or late last week. And then I also wrote some goals down there for what at least I hope to get out of this meeting. And if anybody else has some, feel free to add. But I think the point of this meeting was really to kind of wrap up or continue the discussion from the last meeting in August, which was how does the multi-network proposal or proposals affect the service API specifically, but then also any other parts of the Kubernetes API. How big is that effect, and how nasty might that effect be? So that is basically where we're at. Hopefully people have had a little bit of a chance to review some of those documents over the past couple of weeks. At least I noticed some commonalities between those. Basically, both the ZTE Intel proposal and the Huawei proposal propose adding a network field to the service object, and then the network object would get a cluster CIDR or service CIDR field that would then be used to allocate the cluster IP for various services. So they're at least fairly close in that regard. I also took the Intel ZTE document and made some modifications to that, including adding some other aspects that I thought would be affected by the change, which include endpoints and the CRI, Container Runtime Interface, API between the kubelet and the container runtime plugins themselves, and also DNS probably needs to be addressed. So I added a note or two about that. Does anybody else have any general comments at the start, or should we just kind of jump into what people think about various documents? I don't know. Anybody have comments?
That's a silly question.
Well, I hope people have comments. Otherwise, we can just end this meeting quick. Okay, Tim, you touched it, so now you speak.
All right, so I did go through all of the docs, probably not with as fine-tooth a comb as I would have liked, but I did go through them. And they are all basically describing the same thing, which is exactly what I expected when we said we need to explore this in the last call. I don't think any of them touch on all of the things that they would need to address in order to make this work. But it is exactly what I feared it would be, which is an enormous amount of complexity that we add effectively to every resource involved in anything related to workload or network, right? We touch pods, service, endpoints. We're going to have to deal with ingress. We're going to have to deal with DNS. We're going to have to deal with network policy. This sort of flies counter to the direction that things are headed with things like Istio and service mesh. Node ports and host ports, I'm completely unclear how those things could possibly work in this world. I don't actually even know how I would try to implement this on a platform like GCP. So I have a lot of questions. I just ran through a lot of things, but I can run through them a little bit more slowly. But the biggest number one concern is, like, am I the only one who's concerned about the amount of complexity here?
I mean,
you're the only one.
Go ahead, Casey.
No, I was just agreeing. My main concern is the number of things this touches and the kind of complexity we're adding for a lot of users who might not want this feature.
Yeah, I mean, I am also somewhat concerned about the complexity, but at the same time, I see a lot of complexity being added to other parts of Kube to address certain use cases, and there has been a ton of interest from various parts of the community around this kind of thing, and we've been talking about it for 18 months. And so, you know, if we don't I'm not saying that this proposal is, obviously the be all end all of proposals. I'm just trying to think of, what a forward path would be. And if that forward path is not, let's help out all the people who want to do some of these things by making it slightly easier in the Kube API, that pushes all this complexity off on a large number of other people.
So,
yeah, and to be clear, just to clarify my previous statement, I definitely want to find a way that we can enable the people who want to do this, but I don't want to have that way impose additional burdens on, the kind of majority of users who just want a single network, the way networking works today.
Mm-hmm.
So I don't want to imply that we should do nothing at all here. My concern is that the complexity in the designs is sort of intrinsic, and if we're going to try to solve these use cases, I don't know that there's going to be an answer that has less complexity. I was hoping that somebody had a creative idea that I hadn't come up with yet.
Yeah.
And there's actually some good stuff in these docs that I hadn't thought about, but they're more like adding complexity to what I had thought about than taking it away. There's a lot of nuance that even I didn't consider when I had sort of brain modeled this. So I guess thanks for that. To Casey's point, I think if there's anything we do here, let's assume for a minute that we do something, anything non-zero, the net result for 99% of users has to be no change, right? If you don't opt into this, there can be no tax incurred. And I think I'll hold that line pretty hard. The real question that I have is, we have been talking about this for 18 months, but we have a massive selection bias going on too, right? And the people that we're talking to in this call and in this SIG are obviously slanted towards wanting this. I wonder if the right way to suss it out might be to flesh out, one of these docs into the complete doc and then share it with people from the workloads side of the world and see how hard they recoil.
Yeah, I think I'd also point out that there are two different kinds of impact here. I mean, the first one is obviously on users, and the second one is on developers. So, at least I was also looking at this from the perspective of somebody who doesn't necessarily want or enable multi-network, would not have to do anything, and everything would work exactly the same as it currently does. So, I mean, that's obviously user level, but regardless of whether that happens or not, it obviously does impose some complexity upon the developers of Kubernetes because we have to consider that additional use case.
Right, but I without putting a ton of thought into the answer there, because I only had seconds, I don't know that there's going to be any model that we can develop here that doesn't impose burden on a lot of the rest of the Kubernetes developer ecosystem.
Yeah, that's very true.
This touches pods, it touches services, it touches controllers, it touches the way DNS works, it touches, at least in some of the proposals, the way namespacing is used. There's a lot there. Do we want to talk about the details of the specific proposals, or I don't know how to proceed. I hate being the guy who says I'm scared of this, let's not do it. But I have a bunch of more concrete points that I would like to ask and just see if people have answers for.
Sure. Why don't we start there?
Okay. So putting on my other hat for a minute, as a Google Cloud person, what happens when I have a platform that doesn't offer this? I don't particularly want to offer overlays on top of overlays on top of overlays. What do I do to my users? How do I express, sorry, you can't do that here, and doesn't that break the portability promise? Networking becomes an application construct in this model, right? Every application in the world will start to specify what they want out of their private network.
Can you describe that a little bit more, Tim?
In the same way that the Docker networking model makes an application a network construct, and the OpenStack model makes a network an application construct, people will start to think about their applications in the same way and say, okay, I'm building my app, so I'm going to create myself a private network because it feels right, and I'm going to start putting my services on my private network. And I'm saying that in something like Google Cloud, I can't offer that service without a significant performance impact, and I don't want to break the portability guarantee.
Hi, this is Ben Bennett. Can I just take a swag at that? Isn't the guarantee we make today that if you have an interface, you can talk to any other pod modulo, obviously filtering from the network policy stuff, but wouldn't we make that same rule about a second network? We basically say you're guaranteed to be able to talk to the other things in this network, but we don't necessarily guarantee it's isolated. So effectively you get 2 pod IP addresses on the same network you have today. Would that be a way of slicing that piece?
I think that would violate the assumptions that a user was making about having multiple networks. I mean, I think it would satisfy the letter. I don't think it would satisfy the intent.
It seems to me the problem here is that to create a network, you have to create 2 things. You have to create the actual physical network or SDN or whatever, and you have to create some network objects to let you use it. And what Tim's point is really, as I understand it, is that you can create those network objects that point into hyperspace. They refer to things that just don't exist. And there's a more general point of how do you make sure the network objects you create correspond to valid networks that you can actually use.
That's an interesting way to position it. Like if network is an administrative construct, right, and I as the cluster administrator can decide which networks are available to my cluster, and then I let you consume them, that's one step. But it sounds like from reading these proposals that most people are proposing network as a really application-y construct, and some of the use cases sort of demand that.
That's interesting because I actually was not thinking of it like that at all. I was thinking of it more as the administrative side, so that if you create a network object, then some network plugin would be off listening for this kind of thing and creating all the backing resources that would be ready when that network was used. It wouldn't necessarily be some kind of ethereal random concept.
So in the case, like, it was you, Dan, who described the IPTV model, right?
Yeah, that was one case.
So doesn't that require like a multitude of networks, one for each sort of channel or group?
Not necessarily. In that case, it was more about specific individual encoders. So you might have somewhere between 3 and 6 different encoders running on a particular node. And each one of those encoders might be taking a stream in from one interface or from one network. And basically transcoding that and then spinning it out on the other side as multicast. So I don't necessarily know if that would be network per channel. It was more about you have one network where all the video comes in, and particular encoders might subscribe to one particular channel and then transcode that and spit that out on more of a customer-facing network, if that makes sense. So essentially, I was thinking in that particular case, 2 to 3 different networks, a control plane network for managing these things, and then an ingress network and an egress network, but not per channel or per app necessarily.
And not per user either.
I don't think so. In this case, it was much more about performance because some of the transcoding requirements, especially for high def and possibly even 4K video in the near future, are quite high. So it was very much not logical or not. I don't know what you want to call it, app or logical network. So it was much more administrative defined networks.
And when you say performance, you mean network performance, or you mean like
yes, yep, network performance. So like 10 or 40 gig per second, both on the ingress side and the egress side, in the best cases.
And in this model, if I have 3 transcoders, and they each have 3 input networks, and they each have 3 output networks, or they share the same input and they share the same output?
In the case I was thinking of, they share the same input and share the same output potentially.
And so the performance win is that they don't put the output on the input network?
That is one of them, yes.
Okay.
Hey Dan, can I ask,
physical network?
Could you repeat that?
Are we still talking about the same physical network?
Not necessarily.
So Dan, what you're describing is essentially the equivalent of a provider provision network in other technologies like OpenStack, right? And that particular, I mean, if we go by one particular use case, people will ask for, the same capability, but in a self-service manner as opposed to a provider provision manner. So it'll essentially open the door to sort of the full thing. I'm not saying that's necessarily a good or bad thing. I'm just saying that if you just take one use case where a provider provision multi-network is okay, soon enough there'll be other use cases where either more flexible provider provision networks or self-service application provision networks will then be requested.
That's exactly what I believe too. That it is an attractive nuisance, and it's sort of the thing that people have done in other systems because it makes a lot of sense sort of at the VM level. And I'm sort of still, I have this nagging voice in my head that says this is different. This is not VMs, and relying on the same techniques is questionable.
Also, to be fair, in a lot of the cases that I've run into, at least some of the limitations are mainly performance-based. It would be great if you could, create kind of logical or virtual networks for all of these use cases. But unfortunately, the performance issues at this point prevent.
Can't you use things like quality of service or other forms of detection to provide guarantees for input versus output? This is all very abstract since we don't know the details of those networks that they're using, but
you're saying like
concretely
for each encoder, you kind of limit using QoS how much it can do and that kind of thing, and put a strict limit on it.
Concretely, Google's built a really complicated system that we wrote a paper about a while back called Bandwidth Enforcer, which builds this complicated token tree of policies, and what we get is effectively different quality of service assigned to different jobs and to different port ranges, and it's I'm going to say again, it's very complicated, but it actually works in practice really well with a single network.
Yeah, that could be done, but that's kind of orthogonal to that particular problem, which I'm happy to discuss. I feel like maybe we're getting a little bit down into the weeds on this particular one.
I just want to make sure that we're not embracing the solution that feels most native simply because it feels most right. That there are other solutions that we should consider those too.
Yeah, no, that's totally fair.
Or put nicely, if we can foist the complexity on someone else, let's do that. Only like 3 or 4 of us are doing all the talking. Who else is here?
We're.
So I still don't have an answer. I still don't have an answer to the question of what do I do on GCP where I can't offer this, right?
Well, I don't know. To be cynical, that in some ways seems like a limitation of GCE.
It is, except that I'm trying desperately to keep performance where performance matters. Like today, the performance hit of container networking is already too high, and a lot of people are working to get away from that. I don't think that imposing more performance loss for the sake of a very niche user base is going to be the right trade-off.
When you say performance loss, do you mean in terms of like responsiveness of the Kube API or more work having to be done inside Kube?
In terms of in order to offer sort of application level networks, sort of unbounded cardinality, I have to move into the software domain, right? But GCP is already sort of in the software domain, and so is Amazon, so is Azure. I don't know if anybody from those groups are here. I don't know the details of their network infrastructure, but these things are already in the software domain. So adding a software domain on top of a software domain is guaranteed to be a performance hit.
So maybe this is because I'm coming from a different background, but to me, the way that I would think of a platform using this is that you've got a software-defined network that is your kind of normal network that you have now, and in the use cases that we've got, normally you have a few extra special networks. That's the network that is tied into some other third-party customer system or whatever, which is a physical cable being plugged into an interfaces on certain of your nodes that certain of those nodes can be connected to. So I don't quite understand why that's performance, because it's kind of parallel to the existing network.
So I'm sorry, I don't know who that is.
Sorry, this is Peter White from Metaswitch. So we're a telecom software provider, so we're interested from the kind of SBC angle.
Right. So I think what you just described was sort of where we started this conversation, which was like extra networks.
Yeah.
And that I can actually buy as a model because I very much see the application of it. And I think you're exactly right. It's sort of not an oftenly provisioned sort of thing, and so the impact of re-provisioning those sorts of networks is probably acceptable, and you don't need to do it with any real performance loss. Like a platform like GCE could easily accommodate that.
Yes.
The concern that I have is that the conversation shifted back into but I want to describe my networks sort of as an application level. Right? I wanted to reach out to services is sort of the line that we crossed.
So are you saying, Tim, that if we ignore the impact of services and that sort of makes these networks the kind of like side networks that you were just talking about? I guess I'm a little confused as to when we crossed that line into logical app networks as opposed to kind of sidecar networks.
I think the line was as soon as we said, and then services exist on different networks. Right?
Okay, let me capture that in the notes then.
I mean, I feel bad for this, but this was a big part of Joji's original doc, which was, what if we just said there's always a default network and then there's extra networks, and you can join extra networks to get special access to special links. And that seems reasonable to me, but then the slippery slope began. And we are now talking about modifying services and endpoints and DNS and ingress and everything. I mean, literally, there's not a resource that this doesn't touch in the app and networking space.
This is Keve speaking from Huawei. I'm here with Karon. I just wanted to add a point that this was supposed to be an incremental type of work, in the sense that most of the components that you just mentioned, they are designed to be added in an optional way, in the sense that if there is the risk of performance hit for some particular application, then the user has the freedom whether to take that optional piece or not. The only piece that would make sense to be the mandatory piece was the service, because in that case, if there is no service support for multi-networking, then there is no point. But other than that, like even the logical network definition or the plugins, those are all the options that can be basically added upon request. They don't have to be a part of the vanilla solution.
Except that people's bundles of their application configs becomes non-portable, right? If an application is depending on this networking functionality to work, they can't pick up their application and move it to another platform with reasonable confidence that it works. And just concretely, we made a very similar guarantee with Ingress, where we said, it's implementation defined, and network policy actually to some degree. We said it's implementation defined, and if the implementation supports it, then it works. And I've taken a lot of flack for Ingress not working out of the box everywhere. And I expect that as network policy gets more adoption, that we will take a lot of flack for it not working out of the box everywhere.
To kind of circle back around to some previous conversations long ago, we, kind of had talked about how adding extra networks, at least I remember that adding extra networks doesn't necessarily require API changes in Kube. So the contention at that point was, why don't network plugins just go do it themselves with like custom resource definitions and all that kind of thing, and why do we need to change Kube?
There's a strong argument there.
So yeah, I mean, and sort of in response to that, we started looking into, well, maybe some of these use cases want to expose services on multi-networks, and I think that's kind of where we ended up where we are today.
Yes, but you also said the magic word, which is maybe.
Well, okay. So I said maybe, but there were some use cases we did identify that want to do this. Now, whether those use cases are ones that the Kube community wants to specifically enable, obviously, is another question.
Right. No, I was just giving you a hard time.
Oh,
clearly, we've identified use cases that are real use cases. I'm not denying the validity of the things that people want to do. My main argument is that I'm questioning the complexity required to satisfy those use cases versus the overall sort of cleverness budget that the project holds. And honestly, between you, me, and the room, I'm concerned that we're running out of cleverness beans. Like, the system is pretty complicated right now, and foundationally, there's still a lot of wobbly pieces. We're spending a lot of time making things that should have worked before work more reliably. I'm still, we're now a year later from when I first voiced this concern, but truthfully, we haven't done a ton to stabilize. We've added a lot of features this year, and we haven't focused a lot on stability and bug burn down and those sorts of things.
So when you say we, Tim, are you talking about the general Kube community or SIGNet in particular?
The general Kube community, but SIGNet in particular. Honestly, this isn't meant to be like a chastisement of the SIG, because I'm just as guilty as anybody. But other SIGs have done a lot more to burn down backlog than we have.
Tim, can I ask a question here? So you mentioned that not just GCE, but literally all public cloud providers implement networking already at a software layer, and then you don't want to incur the penalty of overlays over overlays. But it seems like the use cases that are driving this requirement are primarily going to be targeted at non-public cloud deployments, NFV edge type of applications, where it is perfectly possible to have multi-networks that are not implemented as virtual overlays on top of a common single pool of networking. So if the goal of this SIG is to enable non-public cloud deployments of Kubernetes, which I'm sure it is, we just, we should let that go through in the sense of it's just not particularly applicable to public clouds. And it's not going to be, do we need to have, you said that you want some applications to run equally everywhere. These applications presumably will not often be deployed on public clouds. Am I speaking?
Heresy.
Let me know if I'm way off here.
No, I understand what you're saying, but the litmus test for this, for every topic sort of in this space is, does it touch the Kubernetes API? If the answer is yes, then we need to be confident that the feature that we're proposing is reasonably implementable on most or all of the providers that we know we support. And there's a lot of weasel words in that sentence, right? Obviously, I don't know all the platforms that Kubernetes supports. Obviously, most or all doesn't really mean much. But I can't, in good faith, add a feature that I know doesn't work on the majority of public clouds, right? Or that works, but only very badly, that would require significant imposition on those. I can't add that to the public API. And we've shot down other features in storage space and in networking space. It's always in infrastructure land, right? But we've shot down other features that are not easily implementable.
Yeah, and I'd say, one of the core goals of Kubernetes in my mind is to provide this application portability. So if we're adding something that we think breaks that, it better be with a really, really strong reason.
I guess it wasn't clear to me that users wouldn't deploy wouldn't deploy multi-network on public clouds if it was essentially an unsolvable problem on all public clouds.
It's not an unsolvable problem. It's just a problem that is the solution to the problem has I'm pretty sure, a performance impact that isn't obvious from the description of the problem.
I mean, is that performance impact acceptable? I mean, given that most of this would be opt-in anyway, if you want to use those features, it's just not going to be as fast.
The evolution that I'm seeing in terms of cloud providers is much more towards containers as a native thing. And if we impose overlays and SDN inside the cloud space, we're going to break the evolution of cloud providers, right? Amazon just launched 2 weeks ago that their ALBs can target arbitrary IPs, which I have to presume is targeting towards containers, right? Like, that's an awesome feature. This will break that.
But Tim, just to follow up on this point again, I mean, this logic applies to many other features, right? Certain things are going to be more amenable to edge deployments, and certain things are going to be more amenable to public cloud large deployments. But the software stack has to presumably support both types of use cases. This goes back to discussions on multi-tenancy and so on, right? With the relevance of which might be different in a small edge cloud versus in a big public cloud and so on.
Yes, so multi-tenancy is an interesting one that you brought up because that actually came straight out of my notes. It's like you're reading my screen. Multi-tenancy is interesting because multi-tenancy has a lot of the same demands that we're imposing here, but at a much coarser and less application-specific granule. That problem isn't yet solved, and honestly, truthfully, the solutions to that may lend themselves towards this anyway. Now I'm looking around the room and I realize that our multi-tenancy people are not here. Oh, it's way too early. They're not even awake yet. We should probably make this conversation start to include the people who are looking at multi-tenancy, right? And I know, Dan, you sort of wear both hats a little bit, right?
Yeah, I guess the basic point there was that should we only be working on features that are applicable in all Kubernetes deployments, ranging from a small edge deployment to a large public cloud deployment? It seems like we are building a stack that needs to have different personalities for different types of deployments.
Right. So the line to take there is Kubernetes can't absorb every functionality for every workload. We have to be extensible. We've been focusing a lot on extensions and extension mechanisms in the last year. What we've come to be discussing through this, through this conversation is deep changes to the core of Kubernetes, right? We're talking about changing pod, changing service, changing endpoints. Those sorts of changes will be met with a lot of skepticism from people who don't need or can't implement those changes. Whereas if we can build solutions here that are based entirely around custom resources or around aggregated APIs or around, God help us, annotations, then we can at least say for those edge deployments where you need some extra complexity, you can take on the burden of that complexity. And for the core systems where you don't need that complexity, you don't have to. But I admit that the complexity that we foist on those edge systems is probably 3x more complicated than if we just absorbed it into the core of the system, which is why actually we're having the conversation, right? But I personally, and again, at the end of the day, it's not my decision, right? Like, we will have to come to some group consensus and the larger group. I'm not convinced that the complexity required in the core of the system to accommodate the full completeness of this picture is warranted.
I mean, it seems to me totally possible to implement all of these things with annotations, but that's not going to like decrease the complexity or decrease the portability or increase portability.
But the truth is, if it's implemented as annotations or CRDs, I actually care less about the portability, because you can't take an arbitrary sort of extension and expect it to run correctly on every cloud provider, right? That's part of the contract, is it's not part of the core, therefore I don't guarantee its portability. And even strictly speaking, if you talk to SIG architecture, services are not exactly core, but they're sort of the next layer. And sorry, core is not the right word, nucleus is the right word. Services are in that first electron ring, I guess.
I mean, are there examples of other groups that have essentially defined de facto standards based on CRDs or annotations?
I have to think about the answer to that. There's a ton of people who are doing interesting things with CRDs, as you well know. It's hard to say whether they're defining them as standards. One that pops to mind is Istio. They're probably too early to be defined as a de facto standard, but they are using things like CRD to do a really interesting data model that builds on top of Kubernetes that offers a standard for which there is nobody else competing. So I guess that makes it de facto.
Yeah, I mean, if we went down the road of defining annotations and custom resource definitions for all this stuff, and then sort of agreed this is the SIG network de facto standard for how you do multi-networks, I guess, I mean, that, in your words, kind of solves the portability problem, but I don't really see how that makes like any less of a difference with respect to the Kube API, because, you know, a lot of people would start using that standard, implementing that standard, and depending on it.
But those annotations and those extensions are not Kubernetes extensions. They are, we'd come up with a different name for them, right? They would not be part of the Kubernetes API specification. They're not part of the portability. Now, part of the problem that we have here is some of the things we're sort of hand-waving about don't exist yet, right? The conformance is just a budding thing right now. So, you know, conformance is sort of defining conformance levels, and what that really means is still being defined. So it's hard to say this is not part of the conformance level, because the conformance level isn't really a thing yet. But this would not be part of a conformance level, right? You can be completely Kubernetes conformant at the highest Kubernetes level and not support multi-network, and that's totally okay.
I mean, so maybe is that the path forward here? If you, I mean, maybe we kind of trot out these changes in front of the other people that you suggested, but if, you know, people really kind of recoil from that, then is it okay for a SIG to go off and essentially create its own de facto standard?
I think this is uncharted territory. So putting on my steering committee hat, sure, why not? I don't think there's anything that would be against the intent of the community to say this SIG is going to go off and do more than a proof of concept. And, you know, annotations are imperfect for a lot of reasons, but you can go all the way to a full productionable implementation with this without touching any core Kubernetes components, as a way of solving people's problems. And that would also give us a better conversation to have with like the workloads folks, to show them the amount of complexity or the lack of complexity. Like maybe I'm unfounded here, but the impact that this would have on the core of the system, right? Like, to do this as proposed in most of these docs requires changes to the endpoints controller, requires changes to DNS, requires changes to the service controller. Those changes, we'd have to find a way to implement those as extensions, which is probably worthwhile.
Yeah, I mean, that was my major concern with that. We'd have to basically have a bunch of other code that's under the SIG umbrella that would implement these things that everybody would want. And, you know, that code obviously would not necessarily be part of Kubernetes itself, right? Because it would deal with custom annotations that aren't part of the Kube API. So it also probably involves some heavy lifting in those components to extend them or add extensibility capability to them.
I think that's worth looking at. Yeah, I mean, I think that's worth considering as to how those things could possibly be made to work. I don't have clear answers to them right now because I don't have, I think, the list of them in my head. But you know, the first couple are obviously challenging, right? How to extend endpoints controller or replace it. I mean, replace it is an answer too, right?
Well, I mean, I think in a lot of the documents, you'd end up replacing Kube proxy or some of the ingress stuff anyway, and a lot of network plugins already do that.
Yes.
So it may be the case that Kube proxy itself would never support multi-network.
Possibly.
So with regard to next steps, I mean, do we want to keep looking through this, or do we want to try to take these documents and do what you suggested, spread them around to a couple more people and see what they say before we start realistically discussing, you know, some kind of de facto standard within the network SIG?
I think getting some other viewpoints on this topic would be fascinating. I am a little worried that it's still very abstract. And you know, if we brought in Brian or Eric, or I don't know how deeply Clayton's reviewed this stuff, but bringing in some of those guys, or the Joes and the Brendans who aren't part of SIG Network at all, but are definitely part of the overall architectural need, getting their feedback on the sort of the depth of the integration required here would be insightful. I don't want to stop anybody from going off and doing work, right? I think the thing that makes open source really interesting is that anybody can go off and do anything they want, and there's no promise that we'll take it, but they can go off and prove that we're wrong, right? I also don't want to tell people to do things that might be a waste of their own time. But anybody who's worked on the Linux kernel is familiar with this problem. So would it be worthwhile? We've got like 4 or 5 docs that cover the services plus, multi-network plus services plus endpoints plus ... Can we collate those into a single doc with, I'm going to beg for terseness. So like as most succinct arguments and description of the design changes possible, and shop that to SIG architecture maybe?
Yeah, I think that's definitely doable, and at least the documents that, you know, I've linked to here, I think they're similar enough that that can be done. I'm happy to take that as an action item unless somebody else wants to do that.
The resounding energy here.
Yeah, totally.
No, I think that would probably be worthwhile. I mean, I read over all these docs, and they were 85% overlapping. There were some points of disagreement. Well, you know, whether networks were namespaced or not namespaced, and you know, some included use cases, and some just went straight into design. But interestingly, we have a steering committee meeting today, in fact. So maybe I'll bring this topic up. Just as a float, just to see what the initial feedback is.
Yeah, that would be awesome. And if you can just kind of raise the visibility of this question, that would be great.
Okay.
More eyes on it.
Sure.
Because I think we can keep going around in the echo chamber of SIG Network for as long as we want, and I'm not sure that's going to get us as far as getting other people that you had mentioned earlier to look at it.
I'll be happy to work with Dan to...
Sorry, who was that?
I'll be happy to work with Dan and everyone else to get the documents all merged into a single document.
Great.
Pretty much everything, yeah.
Yeah, same
that would be good. I want to be very clear. I'm happy to be wrong on this, right? If it turns out to not be as daunting as I am afraid it is, or if it turns out that I'm just the only one who's concerned about the complexity, like I will happily yield on this. I'm not going to be too much of a pain in the ass. But that's a lie. I will not be any more of a pain in the ass than I have been so far.
All right, so we got 10 minutes left. What do we want to do with that 10 minutes? Does anybody else have anything they want to say, or any other comments on any of the documents they want to dig into, or shall we call it a day?
So I have a question related to the annotation part. So Dan has already provided the CDR annotations as a model of to use the CDR with annotation. So whether we can take that model as a reference model and try to standardize some of the network spec annotation part, or similar to the network policy, have we did that, or
Yeah, we could use it as a base, but I mean, the stuff I did doesn't in any way address the question of services, which I think would be a little bit more complex to do some extension stuff. But, you know, I mean, I'm definitely interested in taking a further look at that and trying to see if we can come to some kind of common agreements on that.
Yeah, some standardized way of doing that one. Yeah.
I would also encourage that if we're going to look at having network objects that are the sort of the source of truth, that we try to describe them in a way that isn't specific to CNI. Like most of the proposals end up exposing a lot of the details of CNI into the network object. It would be nice to abstract that a little bit. You know, as an example, we've done with the storage classes and persistent volumes, right? Network and network class might be something worth looking at.
Okay.
I was going to suggest maybe we can isolate the resources that can be implemented using custom resource definition, and the ones that essentially have to be in the code that require API change. So in that case, we know that what is the complexity of the must have stuff versus the complexity of the ones that can be done using CRD.
That's a good question. I also wonder if we can get away with, at least for the sake of demonstration, not modifying some resources, but actually making new resources that are what would be the new version of this. So like instead of modifying endpoints and endpoint controller, saying we're going to make new multi-endpoint or multi-net endpoint and a multi-net endpoint controller, leave the existing logic alone, but say this is what the new one would do if we were doing it. And then the other components that respect multiple networks could respect multi-net endpoint as opposed to endpoint.
Sounds good.
Okay.
Sounds good to me.
I guess we get 10 minutes back.
Sure.
All right, Ben.
Thanks, everybody.
Thanks all.
It's going to take a while to spool the rest of what everyone said out the disk still in the minutes, though.
Thanks.
Yep.
Yeah, thanks.
All right. Recording is